Good afternoon. In this session, we will be studying Chapter 3, Decision Procedure. Truth tables to test the statement forms. We already know that there are three types of statement forms. That is, the statement is either tautology or contradiction or contingency. So using the basic truth tables, we will continue with the previous exercise. Now we come to the seventh example. Curl into box bracket P triple bar into smaller bracket Q dot curl P. Close the bracket. They are called parentheses. Okay. Now, how many propositional variables are there in this given expression? Q, P and Q. So the number of columns will be 2, the number of rows will be 2 raised to n, that is equal to 2 raised to 2, that is equal to 2 into 2 is equal to 4. Now we write the table. Number of rows, matrix and truth function. Write the combination of propositional variables in the matrix P and Q. And the given expression we write it in the truth function. Now we assign the values to P and Q. P's value will be half of 4, that is 2 trues and 2 false. Write vertically from up to down. Then Q's value will be half of 2, that is 1 true and 1 false. Same way you write. Now write P's value in the truth function also. Now write P's values, second P's values, then Q's values. P's value will be true, true, false, false, and Q's value will be true, false, true, false. P's value will be true, true, false, false, and Q's will be true, false, true, false. Now we have to negate P's value. First we'll negate it. If P is true, then its negation will be false. If P is true, then its negation is false. P is false, then its negation is true. P is false, then its negation is true. Now, we'll have to solve the bracket first because parentheses we have to solve first and then the box bracket. Okay. So, what is main in this? Conjunction. So solve it. What is it joining? It's joining Q and not P. So taking Q's values and curl's values, you will solve. So conjunction is false when any one side is false. So it will be false. Conjunction is false when any one side is false. So you'll put false. Conjunction is true only under one condition, when both the conjuncts are true. So we'll write true. It is false when any one side is false. Now taking P's value and this bracket means the main in the bracket is conjunctions value, you will solve equivalence. When is an equivalence statement true? When equal values it has, and it is false when unequal values are there. So taking P's value and dot's value will solve unequal values are there, this side true and this side false. So obviously it will be false. This side true and this side false. So unequal values false. This side false and this side true. So unequal values false. This both are false. So true. Now highlight the main connective. Now the main connective is not equivalence because there is a box bracket and outside the box bracket there is a negation. So what is main in the box bracket? Equivalence. We have to negate the values of equivalence. Equivalence is false and its negation is true. Equivalence is false and its negation is true. Equivalence is false, then its negation is true. Equivalence is true, then its negation is false. Now you highlight the curl, which is the main connective. Now you have both T and F below the main connective in some rows. Therefore, the given statement form is contingency. Now we come to the eighth example. Into box bracket, into parenthesis, P horseshoe Q, close the bracket, dot P, close the box bracket, implies Q. How many propositional variables are there? 2. Number of rows will be 2 raised to n, and number of columns is also will be equal to 2. So number of rows is equal to 2 raised to 2, that is equal to 2 into 2, that is equal to 4. Now write the number of rows, matrix and truth function. Write the combination of propositional variables in the matrix. Write the given expression in the truth function. Now what we will do, assign the truth values to P and Q. P's values will be half of 4, that is 2. So 2 trues and 2 false. Write vertically from up to down, and Q's value as half of 2, 1 true and 1 false. P's value will write below P in the truth function. Second P's values, then Q's values as TF. Second Q's value as TF. Now you will have to solve the small bracket, that is parenthesis. Implication. When is an implication? False only under one condition, when the antecedent, that is the left, is true and the right is false. The consequent is false. And it is true when right is true or the left is false. So right side it is true, obviously it will be true. This will be false because the antecedent is true and the consequent is false. This is left is false and the right is true, then it is true. And both are false, then also it is true. Now we will solve conjunction, which is joining the bracket and P. So what is the main in the bracket? Implication and P's value. Taking these two values, we will solve conjunction. Conjunction is true only under one condition, when both the conjuncts are true, and it is false when any one side is false. So we will assign the values now. If this is true and this is true, then conjunction is true. Here this side is false, so it will be false. Any one side is false, so it will be false. Any one side is false, so it will be false. Now you will have to solve this implication. It is true when right side it is true, and it is also true when the left is false. Left is false, so true. Left is false, so true. Left is false, so true. Now highlight the main connective. Since we have all T's, that is all trues below the main connective in all the rows, so the given statement form is tautology. Now we go to the ninth example. Into bracket curl P horseshoe Q, close the bracket, dot, another bracket, Q dot curl Q. How many propositional variables are there in this given expression? There are 2, P and Q. So the number of columns will be 2 and the number of rows will be 2 raised to n, that is equal to 2 raised to 2, that is equal to 2 into 2, that is equal to 4. So now we write the table, the number of rows, matrix and truth function. Write the combination of propositional variables in the matrix, that is P and Q, and write the given expression in the truth function. Assign the values of P. Half of 4 is 2, so 2 trues and 2 false below P. Write vertically, and then Q's value, half of 2 is 1, that is 1 true and 1 false. Write vertically. Now write P's values and Q's values in the truth function. P's values is TF. Another piece is not there, so write Q, TF. First Q, second Q is TF. Third Q is TF. Now negate the values of the propositional variables. P is true. First we'll write P is true, then is negation is false. So it will be false here. Again false. Then if it is false, then its negation is true. If it is false, then negation is true. Same applies to Q. Q is true, then its negation is false. Then Q is false, then its negation is true. If Q is true, then its negation is false. Q is false, then its negation is true. Now first you'll solve this bracket and then this bracket. These two brackets are joined by a conjunction which we will solve last, which is the main connective. So what you'll do here? Implications. When is it true? When on the right, that is the consequent is true, then it is true. Antecedent is false, then also it is true. Or you can just simply apply these rules. Left is false and the right is true, then it is true. Both are false, then it is true. Both are true, then also it is true. The left is true, that is the antecedent is true, and the consequent is false, then it will be false. Now, this conjunctions values, when is conjunction true? When both the conjuncts are true, and it is false only when any one side is false or both are false. So your right side is false because we are taking Q's value and not Q's value. So negation is important on the right hand side. It's false. Left side is false. So we write false. Right side is false. So we write false. Left is false again. So we write false. Now, when is conjunction false? When any one side is false. So here it is false on the right. We are taking the dots values and horseshoes values to solve this dot. It is conjunction, the main connective. So any one side is false, then it is false. On the right hand side, all are false. Obviously, this conjunction also will be false, 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 false. Highlight the main connective. Since we have all false, that is F's below the main connective in all the rows, the given statement form is contradiction. Now we come to 10th example. Into bracket P wedge Q, close the bracket, horseshoe curl R. How many propositional variables are there in this given expression? There are 3 propositional variables. So obviously their number of columns will be 3 and the number of rows will be 2 raised to 3, that is equal to 2 into 2 into 2, that is 8. Now write the table, write the number of rows 8. Then matrix, we will write the combination of propositional variables and then we'll write the given expression in truth function. Assign the values to P, Q and R. P's values will be half of 8. That will be 4 trues and 4 false, right? 4 trues in first 4 rows and false in the remaining 4 rows. Now half of 4 is 2. So Q's value will be 2 trues and 2 false. Now R's value will be half of 2, that is 1. So 1 true and 1 false. Now always remember that the last column will always have 1 true and 1 false. Now we will have to write P's value below P, 4 trues and 4 false. Q's value below Q, 2 trues and 2 false. 2 trues and 2 false, and R's value 1 true and 1 false. Now we'll have to negate R's value. So if R is true, then its negation is false. If it is false, then the negation is true. If it is true, then negation is false. False, then negation true. True, then false. False, then true. True, then false. False, then. Now, first we'll have to solve the bracket, because the bracket is joining negative R by horseshoe. So this horseshoe or implication sign is main. When is wedge true? we'll have to solve the bracket. Wedge is the main in the bracket. Is true when at least one side is true. So we'll write true. Any one side is true, then true. Any one side is true, then true. Any one side is true, then true. Any one side true, then true. Any one side true, then true. Any one side true, then true. It is false only when both are false. Both the disjuncts are false, then it is false. Right? False, false. Now, implication values. It is, just follow the table. Left is true and the right is false, then it will be false. Left is true and the right is true, then it is true. Left is true and the right false, then false. Both are true, then true. Left is true means the antecedent is true and the consequent is false, then false. The left is true means the antecedent and consequent both are true, then true. Both are antecedent, consequent, false, then true. Left means the antecedent false and the consequent true, then also true. Highlight the main connective. Since we have both T and F below the main connective, in some rows the given statement form is contingency. 11th, curl into bracket P dot curl P, close the bracket, horseshoe into box bracket, curl P dot into small bracket, curl P horseshoe P, close the brackets. How many propositional variables are there in this given expression? Only one, that is P. So the number of columns is equal to 1, the number of rows is equal to 2 raised to 1, that is equal to 2. Now write down the table, the matrix. In the matrix we will write the combination of propositional variables where we will write only P, and in the truth function the whole expression, given expression. Now assign the values of to P. Half of 2 is 1, so 1 true and 1 false. Write P's values in the truth function, all the P's values. There are 5 P's, all 5 values you write. Now negate the values. When is a negative statement true? When its component is false, and it is false when the component is true. So obviously this is true, then its negation will be false. It is false, then its negation will be true. Same applies here. True then false, false then true. And true then false then true. So now we will have to solve this small bracket. When is conjunction false? When at least one is false, so right side. If it is false, then it will be false. Left is false, then also it will be false. Now negate this bracket. If dot is false, then its negation will be, what will be its negation? True. Okay. We can solve this bracket also first. Left is false and the right is true, then it is true. Left is true and the right is false, means the antecedent is true and the consequent is false, then it will be false. Now you'll have to negate this bracket, or you can solve this also first. Anything. So we'll solve. Dot is false when any one side is false. It is false when any one side is false. Now you can solve the negation of the bracket. Both are false, then it will be true. This is false, then the negation will be true. This is false, then its negation will be true. Now taking these values, in this the negation of the bracket, and in this box bracket the conjunctions value, taking this value, negation of the brackets value, and this conjunctions value, we will take to solve implication. Implicative statement is false when the antecedent is true and the consequent is false. See, we'll write false. Antecedent is true and the consequent is false. So we'll write false. Highlight the main connective. We have all F's below the main connective, false below the main connective. Therefore, the given statement form is contradiction. Now we'll come to the 12th one. Into box bracket, into small bracket, p dot q, small bracket close, horseshoe p, box bracket close, wedge, curl q. How many propositional variables are there in this given expression? 2. P and Q. So the number of columns is equal to 2, the number of rows is equal to 2 raised to n, that is equal to 2 raised to 2, that is equal to 2 into 2, that is equal to 4. So write down the table, then write the combination of propositional variables in the matrix and the truth. In the truth function, write the given expression. Then assign the values of truth values to P and Q. P's values will be half of 4, that is 2 trues and 2 false. Write it down. Then Q's value will be half of 2, that is 1 true and 1 false. Write it down. Now write the P's and Q's values in the truth function also. P's value will be true, true, false, false, and Q's will be true, false, true, false. Both the Q's and both the P's values we have written. Now we have to negate the Q's value. Q is true, then its negation will be false. If it is false, then it will be true, and if it is true, then it will be false, and if it is false, then it will be true. Now in this, we have to solve the small bracket first, which has a conjunction. A conjunction is true when both the conjuncts are true. So both are true, then it will be true. See here. And it is false when any one side is false. False. This side it is false. So false. Both are false. Obviously it will be false. Now we'll have to solve the box bracket, that is horseshoe. It is joining the bracket, parenthesis and P. So what is main in this parenthesis? Dot. So taking conjunction values and P's values, we will solve horseshoe. Horseshoe is, let us see the values, both are true, then it is true. See here, left is false, then also it is true. Left is false, then also it is true. Now taking this horseshoe's value and this curl's value, you will solve wedge. When is wedge true? When at least one is true. So left side all are true, so obviously wedge will be true only. Now highlight the main connective since we have all T's below the main connective in all the rows. So the given statement form is tautology. So in this chapter we have studied how to construct truth table to test whether the statement form is tautology, contradiction or contingency. Thank you.